in the class, and you can see some of the applications. So we are doing last class Cauchy source inequality. Cauchy source inequality. And we have seen that physicists can derive in one line. Okay, we have seen last class mod of UV is inner product UV is less than equals to norm of U into norm of V. But if you want to talk in detailed mathematical aspect, it is not that straightforward, and we see that all the properties of inner products have to be involved to get the derivation. So we used one of the properties, and we found one of W belongs to the vector space, and inner product W greater than equals to 0. Okay. So with that we have derived something. What we have derived finally with this, and W we have assumed W as U bar minus alpha V bar. Alpha belongs to numeric field. Okay. So we have derived something last class. What was it we derived? Up to how far you derived? Do you remember? How far you derived and you understood? How far you understood? First of all, that is the better way. How far you understood? I derived something, but we also might have 3 days holidays over there, and you could see some of the stuff. So anything you got in your mind means how far you understood. Anybody can tell me how far you understood? Any idea? You didn't understand anything, right? That is, I cannot believe, because everything is based on the property. If you put it and you can start using the property, a first property and some third or fourth property and do it. And I don't believe that we have not understood anything. Only thing is you didn't have any time to look at the class notes. That's why you are not able to tell me. But I have to go on because I cannot stop because you are not studying it, right? So how much we have done last class? How much we have done last class? Yes, madam? Inner product? Not U bar, U. This, don't say U bar, U comma U bar, whole bar. U comma U whole bar. Next. Minus alpha bar. Bu bar, not B bar. B bar, U bar is different. Bu bar, inner product Bu bar. Then minus alpha UB bar, yes. Plus alpha bar BB bar. What I am doing now onwards, I will replace U bar as U and B bar as B. I will omit this and assume that these are all vectors. So that's something you actually try to note down. I don't want to write down so many bars and it will be very much confusing. You already have one bar up the top. So what you get, next step is very straightforward. Next step is, and what actually happens, UU bar is nothing but UU, right? Inner product UU bar. So basically we know that inner product UV is nothing but inner product VU bar. But U and U both are same. That means if you take the complex conjugate, it will be nothing but UU. Okay? Plus alpha bar, same thing, VV greater than equals to alpha bar, which is UV. VU bar is nothing but UV, right? That's all properties I am using. Actually, I am using all the time properties of inner product space, nothing else I am doing. If you have the properties, you can do all the derivations. And then next is alpha UV bar. Okay? Now this alpha belongs to numeric field, as I said. Alpha belongs to numeric field. That means alpha is a scalar quantity. And a scalar quantity you can express in terms of inner product, because inner product is scalar. We have seen it. Inner product is nothing but dot product, right? And dot product is scalar quantity. So alpha can be expressed in terms of inner product. So we can write let alpha equals to inner product UV by VB, and then what will be alpha bar? If we write the ratio of inner products alpha, which is inner product UV by inner product VB, what will be the alpha bar? Inner product UV bar by inner product VB. Am I correct? Okay. What is then alpha bar VB? This term. What is alpha bar VB equals to? So if you look at alpha bar is inner product UV bar. What you will get then? A into A bar. What you get? A bar is A square, right? Mod of A square. So what you get from here? Mod of UV square. Am I correct? Both BB are there, BB square. Mod of UV square. And already BB is there. Right? Yes? Term by term you see that, what we are getting. And this goes. So what you got? Norm of, inner product UV square by BB. Okay? What is alpha bar UV? If you look at alpha bar UV, again it is UV into inner product UV bar, it will be UV square by BB. So this term and this term, they are same. Right? So what do you get finally? What do you get from the expression? First term is known, UU. Second term, you tell me the terms. In the final term, there should not be any alpha bar. I am replacing alpha bar in terms of U, otherwise you cannot prove it. Remember that. What you have to prove? You have to prove inner product UV to prove norm of U, norm of B. Right? So alpha bar, all these terms will not be there. Alpha bar, all these terms will not be there. Alpha bar, all these terms will not be there. Second term will be what? Who can volunteer second term? Alpha bar equals to UV, BB bar equals to inner product UV not whole square, UV square. There is not a bracket, boss. It's inner product UV square divided by BB, then less than equals to greater than equals to alpha bar UV square by BB, then next
plus UV square
again UV square by BB. What is that? Yeah. Okay. One of this term will go. Right? So what do you get finally? Not U of U, V of B greater than equals to square. And if you take out the square, it will be half. Am I correct? Yes or no? So that means what? Mod of inner product this is less than norm of U, norm of B. This is norm of U, this is norm of B. We have done last class. We have seen that how to get norm from the inner product space, that was the definition, and that's the way Cauchy-Schwarz inequality. So this Cauchy-Schwarz inequality, anything we can assume from here. I have given an exercise problem, some other assumption of W, and I want you to prove it. So that was the assignment. So try it out the assignment problem and see how we can prove for any of the things you can do. You can even work on the polar coordinate system, and using polar coordinate system we can have the Cauchy-Schwarz inequality derivation. Any questions, any confusions, any doubts on this? So nothing much. So I assume that everybody understood Cauchy's Schwarz inequality, and this you have to practice pretty well. This needs to be the probable exam question. Yeah. Now I'll be talking something on the Gram-Schmidt orthonormalization. I will talk on Gram-Schmidt I will first explain Gram-Schmidt orthonormalization from +2 physics. We have done +2 physics, right? Okay. Always you have to go to the +2, otherwise the problem. The P vector, Q vector, R vector. Right? We have done it. P plus Q equals to R. Very straightforward. Okay. So here we have what we have learned in +2. P plus Q equals to R. P and Q are the basis vectors, right? Or independent vectors. What actually Gram-Schmidt orthonormalization says that we want to have basis vectors always perpendicular, like that. Here the basis vectors are not perpendicular. If you look at, they have some angle. Could be 30 degree, could be 45, could be 60, and the special case it could be 90 degree. So this R vector can also be obtained by like this. So this is Q prime vector, and this is something called P prime vector. So if you now look at this P prime and Q prime with the exact geometry is giving R prime vector. Sorry, not R prime, R vector. R vector is fixed. So here basis vector is PQ. Here basis vectors are P prime, Q prime, and they are perpendicular. Same R vector you are getting, right? This is the rectangle. This is Q prime. This is P prime and R. Am I correct? I think geometry wise I am very correct. Now one interesting thing you can see is Q and Q prime in the same direction. Only P and P prime they are not. Their directions are different. So one of the vectors I have fixed the direction, and other vectors I actually replaced by P prime, right? So these basis vectors are not orthogonal. These basis vectors are orthogonal. This process is called as Gram-Schmidt orthonormalization. So the entire process, what we have done here, which is called as Gram-Schmidt orthonormalization by mathematician. Now physicists did it. Physicists actually picturized. Approach of physics is very straightforward. But when you do mathematics, approach is not that straightforward. Things are complicated. Since in the mathematics class, we have to go to the complicated approach. This approach is very straightforward. We have seen this kind of things we have done in 10+2. We didn't know this has got this kind of bombastic definition called Gram-Schmidt orthonormalization. Now we'll see how, and in fact, before getting into that, I want to see that any of the vectors, if your vectors are like this, and what actually you can do that, you can actually this is your perfect your resultant, and then you can also have, this is the way you can actually have the stuff. So this is the way so Gram-Schmidt orthonormalization says that whatever the basis vectors we have, we can always have perpendicular basis vectors. And I will show you what kind of advantages it has. So let's look at the formal process and how one can use inner product to obtain perpendicular basis vectors or orthogonal basis vectors. That means if I give n independent basis vectors which are not orthogonal, and then in that case it is possible to get n orthogonal orthonormal basis vectors. Orthogonal or orthonormal. I will discuss what is called orthonormal in a few minutes. So procedure. So we have x1 vector, x2 vector and xn vector. They are not orthogonal. Not orthogonal. So these vectors are given to me. They are not perpendicular basis vectors. Some basis vectors which are not necessary to be perpendicular. Which are not necessarily perpendicular. Okay. So here the process is slightly different. This is my x1 vector and this is my x2 vector. Okay. What I am saying that this x2 vector I can replace, instead of talking about some other third vector, I will draw a perpendicular. Okay. And this vector I replace by E2 hat. I will say that from the triangle rule, if E1 bar is the unit vector along this, so this vector is alpha 1 E1 bar and this is E2 hat. So E1 bar is what? E1 bar is the unit vector along x1. How to calculate E1? Who can tell me how to calculate E1 from the mathematics? Unit vector is only, yes. Yeah. Not norm of x1. x1 divided by norm of x1. The unit vector. And alpha 1 is a component. We have done already this kind of concept. So x2 hat, what should I write? x2 hat, what should I write? x2 hat, what should I write? Triangle rule of vectors. Pardon? Just one person please. Who is talking from here? You? Who was talking? That's what you know. When I say you raise the hand, you just keep quiet. I don't know what thing you are doing. If you may be doing wrong, nothing wrong on that. But I want some volunteers. So many people are talking, but I want the answer. It may not be correct, also no problem. Who is volunteering from here? So you are not correct. Fine. Anybody volunteering from here? Yes. Alpha 1. Tell me. E1 bar
plus E2 hat.
Yeah. That's it. E2 hat is not unit vector. Remember. E2 hat is not unit vector. It has got a length. E1 bar, you can say length is 1. Okay. Now x1, x2 are given. These vectors are given. Okay. And what is your objective? From here you have to get E1 bar, E2 bar and En bar. They are unit vectors. They are unit vectors, they are orthogonal. They are unit vectors, they are orthogonal. And that's why these vectors are called as orthonormal bases. Orthonormal bases. That means these vectors are perpendicular. Not only that, these vectors are having magnitude, unity. These vectors are not only perpendicular, magnitude is unity. So the vectors are unit vectors and they are perpendicular. They are called as orthonormal bases. And the examples are the coordinate axis. The unit vectors are on the coordinate axis. And in that case, all these coordinate axes can form orthonormal bases. So now the unknowns are, this is the unknown and this is the unknown. E1 bar already we have found. Right? How to get alpha 1? First you get alpha 1, then you get E2 hat. How to get alpha 1? Alpha 1 is a scalar quantity which is a component. along the direction of u1. How to get alpha 1? How to get alpha 1?
Norm of x1.
Pardon?
Norm of x1.
Norm of x1. Alpha 1 is norm of how? Alpha 1 is vector, no? A scalar. Norm of x1 is length. Is it length of x1? It is no more, because x1 vector is this one. Now x1 vector is not there. We have alpha 1 e1. If you say norm of x1, that means this length. Alpha 1 is only this length. So norm of x1 is not correct. Yes, sir.
Multiply the equation by u1 bar.
Pardon?
Multiply.
Not multiply. Take the inner product. Taking inner product, we should talk in our language, what we have learned, with respect to u1. So you get x2 e1 equals to alpha 1 e1 e1 plus e2 hat e1. Now, these are perpendicular, and perpendicular vectors inner product is from physics 0 cos theta cos 90. Physics is there to give the intuitive answer. Then you can actually check it out by inner product properties. This is equals to 0. So now, from this equation, alpha 1 is inner product x2 e1 by e1 e1, right? Correct? And then what is e2 hat? e2 hat is x2 minus alpha 1 e1 bar, right? Yes? Yes or no? From here, x2 minus alpha 1 e1 is e2 bar, e2 hat. And what is e2 bar? Which is e2 hat by norm of e2 hat. So x1 bar, x2 bar, these vectors now replaced by u1 bar, e2 bar. So if you want to look at the picture, what I have done here from the physics, here it is slightly different. So these are two vectors given. What I did here another vector which is q prime, and I am saying this vector is replaced by p and q prime. So here q vector is nothing but p prime plus q prime. So originally we had the p and q, now we have p prime, q prime, and these two are the bases. So everything you can see from the, so these two are physics and this is from the mathematical form. Okay? Funda is clear. So now, so you've got the two bases. So if you have n such, you have to go for the n. Only two are not sufficient. You have got n basis vectors. Okay? So now, for three-dimensional case, if you want to do three-dimensional, what actually happens? This is your three-dimensional coordinate geometry. Okay? This is your three-dimensional coordinate geometry, and I'm actually matching x1, and then if I put x1, e2 hat is perpendicular to x1 from the picture. So my x1 bar, if it is here, e2 hat should be along this direction. Okay? Perpendicular, and then I want to have e3 hat which is perpendicular to the plane of x1 e2 hat, right? Otherwise I cannot have orthonormal basis. Otherwise I cannot have orthonormal basis. Okay. Now x3 and e3 hat, that means x2 and e2 hat, they are not in the same direction. Similarly, x3 and e3 hat are not in same directions. Are not in same direction. Right? Are not in same direction. So, what is the direction? This is your x. Some direction. So this x, what did we do? x2 was decomposed in terms of u1 direction. and E2 hat direction. So x3 has to be decomposed in the E1 direction. Of course, x1 and E1 directions are the same. E1, E2, and E2 had same direction, and E3. How to decompose? We have done in 10 plus 2 physics. That's why I'm saying everything should be transformed in 10 plus 2 physics to understand. What did we do? We have done this. Again, you apply triangle rule of vectors. You put the arrow. You can see that this plus this equals to this. Okay? What is this vector? This vector is nothing but, okay? So, if you look at, this is the E1 direction. This component is beta 1. Right now. This component along E3 direction, I am putting beta 3. Right? So, and this I am saying something called E3 prime, which is not unit vector. So, E3 prime is how much? From your 10 plus 2 physics, I am only doing triangle rule of vectors. Please apply triangle, there is no nothing here, only 10 plus 2 physics. Yes, madam. Beta 1? Beta 1 is a scalar quantity, madam. How can you say beta 1 plus? Beta 1 E1 bar plus beta 3 E3 hat. So I am saying that this vector itself is so this vector itself is E3 hat, like the similar way what we did here. Okay, so that at least we can actually minimize one. Otherwise, beta 3 E3 hat, you can say E3 hat. The same what we have done. Then x3 bar is what? Why I did E3 hat? Because we don't know the unit vector of E3 bar. So if we wrote E3 hat the same way, if you are confused here, come back to this picture. Okay, I won't write beta 3 because we don't know the unit vector of E3 bar. So write E3 hat. We want to have the entire vector called E3 bar, E3 hat. And E3 hat you can determine, then if you divide by the norm of E3 hat, you can get E3 bar. Why unless if you have one more unknowns like this? x3 bar from the triangle rule of vectors. So from this and this you got E3 bar, this one, and then E3 prime you got, then what is x3 bar from the triangle rule of vectors? Yes.
E3 prime plus beta 2
E3 prime equal E3 prime plus
E2 hat.
Beta
2 E2 or E2 hat.
So it is beta 2 E2 bar. You cannot see E2 hat.
Just E2
Beta 2. So already we have determined E2 bar along the unit vector along this direction. So it is beta 2 E2 bar. All plus 2 physics. I have not bring anything here extra. Only I am applying the plus 2 physics. I remember the first chapter of the physics book is vectors, right? Not even tensor. And I am teaching from the first chapter of the physics book of your plus 2. Not even second chapter. Any confusion here? Any doubts? So from here we can write beta 1 E1 plus beta 2 E2 plus E3 hat. Am I correct? Yes or no? So now we have unknowns. Beta 1, beta 2, E1, E2 bar already known. E1 bar known, E2 bar known. E3 hat. There are 3 unknowns. How to obtain these 3 unknowns? How to obtain these 3 unknowns? Who can help me? How to obtain the 3 unknowns? Again you are saying multiplying. I didn't say that. That's why I am writing everything here. Not inner product, taking inner product. Taking inner product is what? With respect to what? We get beta 1. With respect to E1. Taking inner product with E1 bar, you get x3 E1 bar inner product, which is equals to beta 1. taking inner product with E2, we got X3 E2, which is beta 2. Okay, and then E3 hat can be obtained the same manner. X3 bar minus beta 1 E1 bar minus beta 2 E2 bar, and E3 bar is nothing but E3 hat by norm of E3 hat. Similarly, if we have the 4 vectors, we can write x4 bar equals to gamma 1 E1 bar plus gamma 2 E2 bar plus gamma 3 E3 bar plus E4 hat. And the same way we can evaluate gamma 1, gamma 2, gamma 3, x5, x6 and so on. This is the way this process will go on, and you can get n-dimensional orthonormal basis vectors. Any concept, any problem here? Any doubts? Orthonormal basis, Gram-Schmidt. So this entire process is called as Gram-Schmidt orthonormalization. I will take one example to appreciate this process. X1 bar, which is 1, 2, 3, X2 bar, which is 4, 6, 3, and X3 bar 6, 4, 2. X1 bar 1, 2, 3, X2 bar 4, 6, 3, and X3 bar is 6, 4, 2. Of course, if we take dot product or inner product, we can see they are not 0. If they are 0, they are orthogonal. Of course, they are not 0. They cannot be 0. And there is no negative sign. So if somebody gives this, without calculating, you can say they are not 0 because at least some negative sign has to be there to get 0, right? And if you say x1 dot x2, x2 dot x3, x1 dot x, they are not orthogonal. So none of the vectors are orthogonal. So from this, you can quickly say these 3 vectors are not orthogonal. So in that case, what actually happens? We have to have from here the basis set E1, E2, and E3. We have to find out the basis set E1, E2, and E3. Right? First, okay. Also, what is the approach? You solve the problem with me. What is the first step? You have seen the diagram. Diagram I will not draw. You have the diagram. You see the diagram and give me the answer. First step is what? What is the first step? What is the first step? Find E1 bar. Excellent. Okay. First step. E1 bar. X1 bar by norm of X1 bar. Okay. What is that? How much is the norm of X1 bar? Who can help me? So X1 bar is, we know that 1, 2 and 3. I write transpose. Divided by, what is the norm of X1 bar? So much noise I am getting. If anybody raise the hand and give yes. Root 14, and it is in the calculator. How much it is coming? You have the calci with you, right? Please bring the calci. If you have the calculator, how much you are getting answer? 3.7417. How much is the final vector? How much is the final vector? How much is the final vector? Final vector? Who can give me the answer? First one? You have to just divide by this. 0.2? 0.28. I got 0.2673. Because 3.7417 I took. Okay. Next. 0.5345. Yes, I also got that. And then 0.8018. Transpose. You should take transpose. Well, the row vector I am actually putting. You got E1 vector. Okay. Next step is what? What quantity you have to find out? So E1 bar already known. Fantastic. One part we have done. Next is, what is that? E2 hat. Is it the second step? Before or directly you can get E2 bar from here? Directly you can get E2 hat from here? Alpha 1, yes. Alpha 1. How to get alpha 1? Alpha 1, please raise the hand and tell me, because so many, yes. Alpha 1 is inner product of x2 E1 and what actually happens, since E1 is unit vector and the length is 1, so you can directly write x2 E1 because E1 you can verify. You can actually take E1 dot E1 and it should give 1. So 0.2673 square plus 0.5345 square plus 0.8018 square should be giving 1. If it is not, then something must be wrong with your E1 bar, and every step you can cross check what you are getting is correct or not. So you take inner product x2 E1 bar, okay, and you know the definition of inner product, summation ui bi bar, okay, and here is everything is real quantity. So how much is your answer? Alpha 1. Alpha 1. How much is your answer? X2 bar is known, which is 463. So it will be 4 into 0.2673 plus 6 into 0.5345 plus 3 into 0.8018. How much you are getting? 6.6816. Right? Okay. Now E2 hat. What is the third step? E2 hat, which is equals to E2 hat x2 minus alpha 1 E1 bar. X2 bar is 463 minus 6.6816. E1 bar is 0.2673, 0.5345 and 0.8018. E2 hat is, how much it is? E2 hat, how much? First take the memory function here, get this the numbers, and then directly you can actually subtract and get the answer. You guys don't have any calculators? It's very cheap to buy calculator. It is not that expensive, I guess. You should carry calculator, otherwise you won't appreciate the class. Okay. How much E2 hat? How much is E2 hat? Any answer? E2 hat? Yes, I am hearing all the noise. Please raise the hand and give me the answer. Yes, madam. 2.2140 I got. 2.428. Yes. And last one. Minus 2.3573, and this minus is very important. If you don't get minus, then something is wrong, because if there is no minus, if you take the dot product E1 and E2 hat, that should be equal to 0. Every step you can check, and now with this minus you can expect, there is no guarantee the answer is correct, but this answer what I am giving is correct, and E1 dot E2 hat equal to 0. And now you can calculate E2 bar. You can calculate E2 bar, which is E2 hat by norm of E2 hat. Okay, E2 hat by norm of E2 hat, and E2 hat is already known. Norm of E2 hat you can get. So I want the quick answer of E2 bar. Who can give me how much E2 hat norm? Let's see who can give me the number. E2 hat norm. Norm of E2 hat, how much? 4.0443. Okay, right. E2 bar. See, first bench you guys are actually looking like very much disappointed because you don't have calculator. So you don't appreciate in the class what I am doing, and you're losing something. Okay? E2 bar is how much? E2 bar is how much? E2 bar? Yes? 0.5475? 0.6006, yes?
minus 0.588.
5828. And if you see E1 bar dot E2 bar, definitely it will be giving 0. This is negative sign actually happening here. So I won't do the calculation for the E3 bar because X3 bar is nothing but V1 E1 bar, V2 V2 bar plus V3 hat. With that we can calculate V1, V2, V3 by V2, V1 and beta 1 and beta 2 by inner product. V3 bar, V3 hat can be calculated from the subtraction, and like that we can have n-dimensional orthonormal basis vectors. So let's take some more examples. So I have the vector 8, 5, 11 express in terms of basis 1, 2, 3, 2, 1, 3 and 3, 1, 2. Of course, I am claiming that they are forming a basis. If you want to check, you can use summation alpha I bi bar equals to 0, and if all alphas are 0, then you can say they are forming the basis. Okay. So now, how to express in terms of this basis? So it will be, so you can write this equals to alpha 1, 1, 2, 3 plus alpha 2, 2, 1, 3 plus alpha 3, 3, 1, 2. It says that any vector can be expressed as a linear combination of the basis vector, and where alphas belong to numeric fit, alpha 1, alpha 2, alpha 3 belong to numeric fit, right? And then what actually happens? Then we have to construct the algebraic system to solve. So we have what we get? Alpha 1, alpha 2, alpha 3. Here we have 8, 5, 11. So alpha 1, what did you get? 1, 2, 3, 2, 1, 1, 3, 3, 2. Am I correct? Okay. Now, how to get alpha 1, alpha 2, alpha 3? We have to use the Gauss elimination. Otherwise, it is difficult to solve. So, when you do the Gauss elimination, what you see? Do that. So this is 0. This is 0, right? And how to get this 0? So R3 1, which is R3 minus 3R1, and R2 1 is R2 minus 2R1. So it is 1, 2, 3, 0. Then how much? Then next 0. Next, quick, boss. What is that? Minus 3, minus 7, alpha 1, alpha 2, alpha 3. It is equals to 8. Will be there. Next, next, minus 11. Next, minus 13. Next step. Next step is R32. R32 equals to R31 minus R21. Don't say R2. R2 means I have to go to the original R2. So how much you are getting? 1, 2, 3, 0, minus 3, minus 5, 0, 0. How much? Minus 2, alpha 1, alpha 2, alpha 3, and which is equals to 8 minus 11, and then minus 2. Alpha 3 equals to 2, and subsequently we can get all the alphas. So this is the way one can calculate the alphas, alpha 1, alpha 2, alpha 3, and one can get that. Okay, understood? Next, I'll give you if these bases are orthonormal, how to calculate. That's what I wanted to tell you, that if these bases are orthogonal, this alpha 1, alpha 2, alpha 3 calculation is very straightforward, right? If these bases are orthonormal, so what I am saying, if you have, now I am showing you why we need orthonormal bases. Okay, we have 8, 5, 11. Alpha 1, we have got E1, alpha 2, E2, and alpha 3, E3. E1, E2, E3, we have to calculate from the Graham-Schmidt orthonormalization. There is a home task. Now, if you have E1, E2, and E3, and I am saying alpha 1 prime, alpha 2, alpha 3 prime. How to calculate alpha? So what I am saying that 8, 5, 11 can be expressed as linear combination of E1, E1, E2, and E3. Next problem. First problem I gave what? 8, 5, 11 can be expressed as linear combination of these three vectors. Now I am saying linear combination of these three orthogonal vectors. Okay? So how to calculate alpha 1, alpha 2, and alpha 3? How to calculate alpha 1 prime, alpha 2 prime, alpha 3 prime? Quick. Yes, sir. So alpha 1 prime will be equals to inner product 8, 5, 11. That's it. So you don't have to solve. Here we have to solve it. If this problem is a large system, it takes a lot of time to solve. But here we don't have to solve anything. You get this vector from the Graham-Schmidt, and alpha 1, alpha I should be generalized expression. Alpha I prime is nothing but 8, 5, 11 EI. All alphas are obtained without solution. So that's why one has to go for the Graham-Schmidt orthonormalization to get these components, so that you can get the solution. Okay? Any confusion, doubts? Thanks for kind attention. So next class tomorrow 10 o'clock.